everyone, welcome back to my channel, and in this video we are going to discuss the chemical properties of group number 2, mainly the oxides of group number 2 like magnesium oxide or the barium oxide or calcium oxide. So first of all, how oxides are formed, we have learned this in in the previous videos that when they react with when they react with oxygen, they form certain type of oxides. So how do they are going to act or react with other compounds? So simple, when we say oxides, so those are basically alkaline, but when we talk about the beryllium one, it's amphoteric. It acts as both acid and alkalis, and we'll discuss it later that how it is going to react with acids and how it is going to react with alkalis and act as both. So group 2 oxides generally react with water to form alkaline solution like hydroxide one. We have done this in the other video as well, that when they react with water, the hydroxide part of the water reacts with this group and they form hydroxides and they get alkaline. So when we go down the group, they become more alkaline. So this happened because the hydroxide become more soluble. When we are going to discuss this as well as you move down the group, this means that more hydroxide ions can dissociate and the solution become more alkaline. So now keep this thing in mind that when we define strong acid or strong alkali, we say that it depends on the ease of dissociation. If the acid or alkali easily dissociate or easily ionize, they are said to be strong. If they are difficult to ionize, they are said to be weak. So when we move down the group, it is really easy to break them apart because the nuclear fraction or the nuclear hold is really weak and they're easy to break. That's why the pH increases down the group. Simple. It's a simple explanation. Number two, like how do they are going to act when we dissolve them in water? In like simple how when we dissolve them in water, definitely they are going to react, and sometimes they are going to react very violently. So when we talk about magnesium oxide, let's just write the reaction. Magnesium oxide reacts with water and it form magnesium hydroxide. Okay, now when we talk about the solubility, or when we talk about the you can say state symbol, keep this in mind. This magnesium oxide is solid, this water is liquid, and this one is also solid. And you must have seen the boxes in your lab that there are certain alkalis present over there: calcium hydroxide, the magnesium hydroxide, sodium hydroxide, potassium hydroxide. These all are solids, these are not soluble. So you have to write them as solids. So second one is the calcium oxide. A vigorous reaction is going to form. Sometimes you can say it's a exothermic reaction. So a similar reaction is going to happen. We will write calcium oxide as solid. It is going to react with water, which is a liquid, and calcium hydroxide is going to form, which is solid. Simple. Now the same reaction happens with strontium and barium, but as we discussed earlier in the previous one, that the when we move down the group, the alkalinity increases. It means those can dissociate easily, and those are easily soluble as well. So those are like, you have to write them as aqueous, sorry. So when we write strontium oxide, which is a solid, it reacts with water, it's a liquid, it forms strontium hydroxide, but it would be now aqueous. Why? Because it's a strong alkali, you can say. It dissociates easily. That's why we are writing it aqueous. Same goes for barium. Barium also, you have to write the state symbol as aqueous because the ions are easily dissociated. Simple. Now, what happens when these oxides react with acids? The reaction is quite simple. You must have learned this in the like acid, alkalis, and salts, that there are three ways in which acid reacts. number one, when they react with metals, that we discussed in the previous video. Number two, when they react with oxides or hydroxides. Number three, when they react with carbonate or hydrogen carbonate. So when they react with direct metal, hydrogen gas is released. When they react with oxide, a salt and water is formed. And we name this reaction as a neutralization reaction, because on one side we have alkali, on other side we have an acid, and the reaction is known to be neutralization. Simple. So group 2 sulfates are formed definitely when sulfuric acid are going to react. So the insoluble sulfates, we have discussed this when we discuss the properties of direct reaction of metal with acids, that calcium sulfate, barium sulfate, strontium sulfate, these are insoluble because a certain surface, or you can say a layer, form outside which prevents the reaction. So to prevent this from happening, a layer to form, what can be done? By using the oxide in powder form and constant stirring. So stirring doesn't allow the layer to gather around, so an easy reaction can happen, and you can say it occurs or it reacts easily. So let's write the equation for this one. First of all, we are going to write the general equation. Metal oxide, it reacts with MgO SRO. It must be O, okay, because it's plus 2, it's minus 2. So it reacts with HCl, let's say. It is going to form metal chloride with water. Simple. Let's just balance it. It's solid, it's aqueous. It would be aqueous because all chlorides are soluble. It would be liquid. So a simple reaction is going to happen. It's not that much difficult. Even if you want to add the hydroxide, that would be same like hydroxide, the same reaction would form, but for like we are discussing here oxides, so mention oxides only. So you can write here, for example, Ba, barium oxide with S2HCl, which is aqueous. It reacts to form barium chloride, which is soluble, so aqueous, along with water. Clear? So the reaction is quite easy. So what happened in case of sulfate? Metal oxide along with sulfuric acid form metal sulfate. Now some are soluble. Just you need to remember what is the solubility. It would be solid, it would be aqueous, and then water is formed, which would be like the liquid. So just remember the solubility rule. Only magnesium is soluble, all other three are insoluble. So for that you have to write S, and the you can easily predict the reaction. So see you in the next video with more reactions. Hope you understand till here. So meet you in the next video.